get started. We are going to do 9.3 today. In 9.3, the first two problems are just calculator problems, and we're going to be talking a lot more about the E in the next couple of sections, okay? This one right here just kind of wants you to get used to where it is on the calculator. So when you are punching this into your calculator, oops, and I'll explain more about E when we get to the section that actually uses it in problems. Okay, but for now, let's just locate it on the calculator. If you're looking at your calculator, this right above this LN button, you'll see that little E, and then it's got a little exponent because the E always is raised to a certain exponent. In this case, on this problem, it's to the 6th. So since it's blue, you'll hit the second button, then this LN button. That'll give you the E, and it automatically puts you up in the exponent. So all you have to do now is type in that 6 to the exponent, hit enter, and that's your answer. And it wants you to round it to 4 decimal places. So if I am looking here and I go 4 decimal places, that takes me down to that 7. But remember, you'll need to look right after it to see if that 7 is going to round up to an 8. And if the number after the 7 is 5 or above, that's telling me to round that 7 up to an 8. So you'd actually have 4.03, or excuse me, 403 point, and then 4288. Okay? The next one, same thing. It's just E to the negative 3.41. So again, just locating the E on the calculator. So you'll go, since the E is right above this LN button, that's a little bitty E. So you're going to want to hit the second, then the LN button. That puts you right up into your exponent. And then just type in whatever your exponent is. So negative 3.41. Hit enter. Again, if I'm rounding it to 4 decimal places, I need to go 4 behind the decimal, go 1 more. That 4, since it's below 5, tells me I don't need to round up this time, so it's just 0.0330. Okay, now the next one, this is getting into the bulk and what the majority of this section is about. It's about the exponential function when your x is located in the exponent of your graph. Okay, so let's look at number 3. We have y equals 2 to the x power. Now, obviously, I can just go and put this in my y equals, which I will later after I show you why the exponential graph takes on the shape that it does. So let's just make, like old school, make our little XY chart and choose numbers to plug in for this X. I'm just going to choose -2, -1, 0, 1, and 2. So if I replace the X in this function with this -2, what's that going to give me? Y equals 2. Replace your X with -2. Now, I have a negative exponent. If I'm going to find out what number that is equal to, in order to I need to turn my exponent positive. And the way you do that is you flip the base upside down, which means I need to think of the base as 2 over 1. So if I flip that upside down, that's actually going to put me at 1 over 2, which turns my exponent to +2. Now I can do this, right? Because 2 squared is 4. So I'm going to be left with 1 over 4. So when I replaced the X with -2 and did the math, it gave me 1/4. I'm going to do the same thing now. I'm going to replace the X with -1. So 2 to the -1 power. So let's see, that'll put me at 1 over 2 to the +1, right? Because I got to flip it to make my exponent positive. 2 to the first power is just 2. So I'm just left with 1 over 2. All right, keep going. Replace your x with 0. So 2 to the 0 power. Anytime you're raising something to the 0 power, it doesn't matter what the base is. Anything to the 0 power is equal to 1. Change the x to a 1. So I have 2 to the first power. 2 to the first power is 2. And then the last one, change the exponent to a 2. So 2 to the second power gives you 4. Let's plot these 5 points to see what shape your exponential functions are going to look like on the graph. Let's see, let's plot these points. -2, 1/4. If my x is -2, I'm going to go to the left 2. If my y is 1/4, I'm barely going up at all, right? Going up just a little bit. -1, 1/2 would be to the left 1, up 1/2. 0, 1. So left and right 0, up 1. 1, 2. So to the right 1 and up 2. Right 1 up 2. And the last one, 2, 4. So to the right 2 and then up 4. So this is what your exponential graphs will look like. Okay, just a couple of notes about them. Okay, they're going to have this curve right here. They're going to pass through that y-axis at +1. And then what this is going to do is this is just going to continually get closer to the x-axis, but it's not actually ever going to touch it or cross it, okay, unless it's being shifted. Okay, now this right here, that is what your exponential graphs are going to look like. Now this one was multiple choice. The only one that has that shape is this one right here. All right. Number 4 is the same kind of thing. You just have y equals 5 to the x power. So the only thing that's changing, let's see what happens to this. If I change that to 5 to the x power and then use the same numbers for x. Let's see, if I put a -2 there, I would have 5 to the -2, which is going to do what? Turn my 5 upside down to 1/5 squared. So that's going to be 1/25. If I do the x to be -1, so 5 to the -1, again, flip over your 5 to 1/5 to the first power, so that's just 1/5. What are you going to get if you replace the x in the exponent with 0? What's 5 to the 0 power? Remember, we talked about this. Anything to the 0 power is 1. If I replace my x with 1, what's 5 to the first power? 5. If I replace my x with 2, what is 5 to the second power? 25. Now, let's see what this does to the graph. Let's see if I have Okay, so I'll just do it here. So let's see, -2, 1/25. So left 2, up just barely. Okay, it's gonna look like I'm making the same, starting off making the same graph. -1, 1/5. So -1, just up barely. 0, 1. So it actually has this same point. 0, 1. But then look what happens. 1/5. 5. To the right one, up 1, 2, 3, 4, 5. And the last one, 2, 25. Where's that going to be? To the right 2, and then up 25. So all the way up to where I can't even see it on this graph. Okay, so this is what this graph is going to look like if I connect those points. Okay, it's actually just going to do the same shape. It's just going to be a lot steeper because of this, right? That's what's making these numbers get big really fast. That's why when you hear somebody talk about something growing exponentially, here's why they're saying that. It's going steady, 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 and then it just shoots off, right? It grows extremely fast. All right, let's look at number 5. I'm actually going to use the same graph to show you what happens here. Oh, wait. On number 4, again, the only one that had the exponential shape was that A. All the other ones had a different shape. Okay, now on number 5, this time, my base is 1/3 to the x power. So my x is still in the exponent. The only thing that's changing so far on these graphs is this base number. Let's look what happens when your base, the absolute value of it is less than 1. So let's replace my x with -2. So I have 1/3, let's do it over here, to the -2 power. So again, I've got that exponent that's negative. So what needs to happen in order to use that? I need to flip that upside down. So when I flip 1/3 upside down, it actually becomes 3. That turns my exponent to +2, and 3 squared is 9. Replace the x in the exponent with -1. So I'll have 1/3 to the -1 power. So let's see, if I flip that upside down, it'll be a 3 to the first power, which again, that's just 3. Replacing the x with 0. Remember, even if your base is a fraction, if you raise that number to the 0 power, it's going to be equal to 1. Make your exponent +1. So what is 1/3 to the first power? Well, 1/3 to the first power is just 1/3. And the last one, if I raise my exponent to 2, I'll have 1/3 to the second power. When you're squaring a fraction, you just think of the top and the bottom as separate numbers, kind of. 1 squared gives me 1. 3 squared gives me 9. So 1/9. Let's look what happens when I plot these points. My first point is at -2, 9. So left 2 up. So left 2 up 9. Left 1 up 3. So left 1 up 1, 2, 3. 0, 1. So if you'll notice, they've all had that point right there, the 0, 1 point. Now to the right 1 up a third, right 1 up a third, and right 2 up 1/9. So right 2 and then barely up at all. So look at now what the shape of the exponential graph is doing. It's doing the same thing, but it's going up on that side of the y-axis. So it just flipped it flipped the shape across the y-axis. That's going to happen anytime your base number, the absolute value of it, if it's less than 1, your exponential graph will go this way. Still going to follow those same rules. It's still going to pass through this 0, 1 point, and it's going to come right up to the x-axis, but not cross it, unless there is a number that has shifted it. And we're going to talk about the shifts here in just a little bit. All right, let's look at number 6. On number 6, I'm just going to push that one in the calculator. Oh, wait, let's go back to number 5 and look at the different graphs to see what is the distinguishing, because look at these. These two look very similar. But what did we say? The exponential graph, it's not going to cross that x-axis. It's just going to come right up next to it and then go along it. Right, number 6. So I'm just going to go to my y equals and then type in exactly what it says, 6/5 e to the x power. So when I go and I type that in, so 6/5, I just put my fraction in parentheses. E, remember where your E is. You would hit second and then that LN button. That's going to give you the E. Let's graph it. So there it is again, the exponential function. And it looks like the only one, so you could have done that on all of these essentially, right? I just wanted to draw those out to show you why things were making the shape that it was making. Now on number 6, let's think about what the distinguishing mark is. If I am looking here, let's look where it crosses the y-axis. And then let's talk about what that looks like on the multiple choice. It crosses the y-axis between the 1 and the 2 this time. Now, let's look at these, because the two that have the exponential shape are A and D. So what is different between them? Now, on my calculator, it crossed between 1 and 2, right? Now, if you're looking at this, whoops, sorry. If this is 10, that means each one of these hash marks is a 2. They go up by 2s, right? 2, 4, 6, 8, 10. So that means it looks like it's crossing it between 0 and 1, but actually it's crossing between 1 and 2 since each of the hash marks are 2. This one crosses it on the second hash mark or around the second hash mark, which is actually a 4. Okay. All right, now when we get into number 7, 8, and 9, let's remind ourselves of what shifts all the graphs. These exponential shapes shift just like any other graphs do. The same things make them shift left and right and up and down. So let's remember, what shifts you left and right is an inside number. When you're talking about inside numbers and the exponential graphs, they're going to be the numbers up in the exponent, inside the exponent, I guess we could say, with the x. The outside numbers that shift you up and down are going to be down on the same level as the base. So let's look at number 7. Actually, let's compare 7 and 8. And then I'm going to share my screen and show you something about plotting these. So the difference in these is the shift. This is an inside number, inside the exponent. This is an outside number. It's not up in the exponent, it's outside of what's happening here, which means they do different things. Remember, inside shifts you horizontally, so left or right, but opposite the sign, right? So this minus 4 is actually going to shift this exponential graph to the right 4. This one, this is number 8. That's an outside number, which means it shifts you vertically or up or down, which means it's gonna, and you go with the sign, so that's gonna shift you down 7. Now, let's talk about how to enter these. The first thing you're gonna do on numbers, whatever number that is, 7, is tell it what the base is. So all of these look the same. The only thing is different is how far you are shifting. So look, this one is shifting the graph 4 units to the right. So that's why you would choose this one, right? Because I want to shift it to the right. So that's why you would choose that multiple choice and put the base that you're going to shift it. Now on this one, okay, which goes along with this problem, you're going to start off with your base of 4 to the x power. So when it gives you that drop down, make sure you choose 4 to the x, not 4x, but the x and the exponent. And then you're going to shift it 7 units down. Okay, I'm going to share my screen. Hang on, let me find out. Go to number 8 on this one. I know it's not sharing yet. I got to get it there before I can share. Okay. Okay, so now you should be able to see my number 8. Okay. The only thing that's different about this number 8 and the one I did on the board is that it's 3 to the x. So I'm going to click to enlarge the graph. I guess it wants me to graph it first. So when you come over here, remember, because you have to tell MATLAB what shape you are drawing. Look what it tells me when I hover over this shape. That's your exponential tool. So if you're going to draw an exponential graph, click that. Now, just like the shifting section that we did a while back, the up, down, left, right shift, you can click anywhere in this graph. It doesn't matter. It's going to put that exponential graph right in the middle. Now, this one would shift me down 7, right? So I want to shift the graph vertically down 7. So you come down here and tell it, watch, you can see that yellow graph. It's going down. Keep going down until you're down 7. Now, here's the other thing I want to show you. All of these graphs, look down here in the box below where it says base. They're all going to have an E there. What is our base of this graph? If you come back and look up in the problem, this number right here, that 3, that's what you need to tell it down here. Instead of base E, you want to change your graph to base 3. And then hit save. Okay, I feel like this one kind of did it backwards. So this graph of f of x equals 3 to the x minus 7 is the basic exponential. This is where you would choose 3 to the x, right? That's our base, is the 3, x in the exponent. Then the next one, since this minus 7 is in the back, It's an outside number, so it's going to shift it down 7 units. Okay? So I just wanted to mainly show you, you've done the shifting before. It's just that when you get that almost ready to graph, make sure you change the base from an E to whatever the base of your specific problem is. Okay? All right, number 9, the last one like this. This one, f of x equals 2 to the x plus 4 minus 5. So let's talk about the shifts of this one. First of all, the way you're going to answer it is it's going to say start with the graph of y equals blank to the x, then shift it blank 4 units and blank 5 units. So this first blank, what is going to be your base? Well, your base is this number right here. You're going to start off with the graph of 2 to the x power, shifting it blank 4 units. That's going to be, so here's your 4. It's an inside number, right? It's inside the exponent, which means it's going to shift it left and right, but opposite the sign, which means this one will shift it to the left 4. The 5, here's what's going to shift it 5 units. It's an outside number, which means it shifts it up and down, but we go opposite, not opposite. If it's an outside number, you go with the sign, right? So I'm going down 5 units since it's minus 5. So again, you're going to have to move that exponential shape around by doing the horizontal shift and then the vertical shift. And remember, change your base when you're in math lab. This one, you would change your base to a 2. It's probably going to be set as a default to E. Okay, the last 2 problems. We're going to need this formula. Okay, we're going to use this formula. This is the formula that you're going to use a lot of times when you invest money in a savings account or a CD or something like that. Let's talk about what the different terms are going to mean. This A, that's just going to be how much money you're going to have at the end. That's going to be your answer to these. The P is going to be the principal. That's the amount that you start with, the amount that you invest initially, your starting amount. Let's see, what other letters do we have? We've got an R, which is going to be your interest rate. And the thing about this is a lot of times when you're given an interest rate, it's going to be in a percentage, like 6% interest. You're going to want to change that. It needs to be in decimal form. So you're going to want to change your interest rate from a percentage to a decimal when you're using the formula. The N. The N is going to be the number of times that your original investment is compounded a year or reinvested a year. So if it says it's compounded once a year, then your N would be 1. If it says it's compounded biannually, bi means twice, right? It'd be compounded twice a year. If it's compounded quarterly, how many quarters are in a year? 4. Then your N would be 4. So that's going to be that number. The T is the time, the years. Okay, so let's get all that written down and then let's look at number 10. All right, number 10 says, suppose that $61,000 is invested at 6.5% interest compounded quarterly. So let's think about what all we know. If you were investing $61,000, that is your principal, your original investment. It's invested at 6.5%. That's your interest rate. We'll deal with that in a second. Compounded quarterly. So N is the number of times you are compounded in a year. If you are compounded quarterly, that means you are compounded 4 times a year. The last thing is the T. I do not know the T yet. The T is going to change. That's going to be the variable, the number that changes, because what does the T represent? It represents the how many years the money has been invested. That's what's going to change. Your initial investment will always be the same, right? How much you deposited on the day you open the account. The interest rate will be the same. This is just all terms of the account. The interest rate will be the same, and the number of times it's compounded will be the same. This is what's going to change depending on how long your money has been invested. So the first thing it wants to do is the function for the amount to which the investment grows after T years. All it wants you to do here, it has this, it wants me to replace everything I know in this formula with what I know. So what can I put in place of this P? 61,000. Open parentheses. There's your 1. It's just part of the formula. Plus, you're going to have the rate over the number of times it's compounded a year. Now remember, when you enter the rate, you can't enter 6.5%. You've got to change that to its decimal, which means move this decimal into percentage 2 places to the left and replace that opening spot right there with a 0. So it's going to be 0.065. So that's going to be my rate number, 0.065. Over my N. My N is 4, right? Because it's compounded quarterly. Then your exponent is your N number, which is 4, times your T. So 4, I don't know what T is, so I'm just going to keep the T as a T. That's the number that's going to change all the time, is that number for T. Now, when you enter the formula, it's going to want you to take care of this part right here. Instead of writing all that, it's going to want you to enter it as 61,000. And then just figure out what that is. So just push that in your calculator. 1 plus 0.065 over 4. Hit enter. So that's what's going to go in the parentheses. 1.01625 to the 4t. So that is what you're going to put right here as your first answer. That's going to be the formula that I'm going to use to answer all of these. Every part of this question from here on out is just wanting you to change the t. So the amount of money in the account at t equals 0 years, right? T is the time. So if you change your t to a 0, this is what it's going to look like. 61,000 times 1.01625. Here's what's changing every time, right? Just the t. So I would have what? 4 times 0. 4 times 0 is 0, so 61,000 times 1.01625 to the 0 power. Punch that in your calculator, and that's how much money you will have after 0 amount of years. So let's think about what that's actually asking. After I haven't even had it in there any. I just went and put it in the bank. So that's why your answer ends up. So I'm just going to put exactly what I have on that bottom row on the board. 61,000, open parentheses, 1.01625, close. Go up in my exponent. And my exponent is 0, right? Look what you get. 61,000. Doesn't that make sense? You just put it in the bank. You're not going to be able to walk up to a bank, deposit $61,000, and it immediately has made money, right? So after 0 years, it's still 61,000. The next one, 4 years. So remember, I'm using the same formula that I came up with at the very beginning. The only thing that's changing is the number that's in the t position. This time I want it to be 4 years. So I'm just changing that 0 to 4 years. So now I have 4 times 4, which is 16, as my exponent. And then type that in your calculator to see what you get. So the only thing that's going to be different between this part and the one I'm about to put in here is instead of 0 in my exponent, now it's going to be 16. So 61,000, open parenthesis, 1.01625, close. So exactly like this row. But now I'll go up into my exponent, and my exponent now is 16. Hit enter, and it wants me to round it to the nearest dollar. So I need to, there's my dollar, right? Because those are cents after that. So do I need to round that 7 up to an 8? I do, right? Because if this is 5 or higher, that means this needs to round up. So after 4 years, you would have 78,948. So that was after 4 years. And it wants to know after 7 years. So again, from problem to problem, the only thing that's changing is the number in the t spot. So now it's after 7 years, which is just going to make my exponent now 4 times 7, which is 28. So again, nothing changes except the exponent is now going to be 28. So 61,000, open parenthesis, 1.01625, close. Go up in your exponent, and now it is 28. Round it to the nearest dollar. There's my dollar. Right after the decimal is a 5, which means that needs to round up to a 6. So 95,796. And last part wants it at 10 years, which means the t changes to which means the exponent changes to 40. So again, you're just going, type it in the same exact thing, change your exponent to 40, so 61,000. Open parentheses, 1.01625, close. Go up into your exponent and type in 40. So rounding to the nearest dollar, let's see if 39 needs to round up to 40. Since that's a 0, it doesn't. So after 10 years, you would have $116,239. Now, let me show you a trick. Go to your y equals and clear it out. Type this into your y equals. We don't have a t, just make it an x, right? That's your variable. That's what's changing. That's what's going to be your x. So if I put that in my y equals 61,000, open parentheses, 1.01625, close. Then I'm going to go up in my exponent, and I'm going to make my exponent 4, and I don't have a t, so I'll just make it an x. Let's look, it looks like on a graph. Oh, can't even see it. We'd have to zoom fit. So we're worried about that. Go to second table. Now remember, what did I put in as x in my calculator? What was representing this t, right? So that's the number that was always changing. The first time we did it, it was 0, which turned the exponent into 0. So let's look. So instead of t, it's x. Look, when x is 0, what did we get for that first one? 61,000. What was the next thing we did? We changed that t, in other words, x, to a 4. What did we get? 78,948. Then we did the 7. Here's what we got for the 7. And then we did 10. There's what we got for when we put in for 10. So you could put that in your y equals when you're doing this at home, and then just keep changing the x to whatever the year is, right? Because that's your variable. That's your number that's changing. All right, last one. On Melissa's 6th birthday, she gets a $5,000 CD that earns 4% interest compounded quarterly. If the CD matures on her 10th birthday, how much money will be available? So let's just change all this what we know. Using the same formula. Let's see, the principal is how much is invested. That's your initial starting amount. It says she got $5,000. Earns 4% interest. So the interest rate is 4%. If I change that to a decimal, it'd be 0.04. It says it's compounded quarterly. Remember, the n is the number of times you're compounded a year. If it's quarterly, it's 4 again. Do I know the t, the number of years? Let's listen to the question again. On Melissa's 6th birthday, she gets this money. It matures on her 10th birthday, which means how long has it been invested if she got it on her 6th birthday and it had matured on her 10th? That means it's been invested for 4 years. I know all of that information. So let's plug it in. A equals, this is going to be the amount I have after the 4 years. My principal is 5,000. open parentheses, 1 plus your interest rate in decimal form. So there's your rate in decimal form, so 0.04, over the number of times it is compounded. How often is it compounded? 4 times a year. The exponent is that same number again, so 4 times the years. So 4 times 4. This is, if I figure out what all this is, that's going to give me my answer. Let's figure out what's in here first. So I have 5,000 times, let's see, what is 1 plus 0.04 over 4? So just tell your calculator exactly that. So it's 1.01. My exponent is 4 times 4, so it's 16. So here's what you need to tell your calculator. 5,000 times 1.01 to the 16th power. So just type that in. 5,000, open parentheses, 1.01, close. Go up into your exponent and tell it to put 16 in your exponent. Your calculator will do the order of operations for you. So hit enter. This one needs you to round it to the nearest cent. So you always have to pay attention. They'll tell you all different kinds of things. So there's my cents. Do you need to round 89 up to 90? Well, since the number after the 9 is a 3, I don't need to round it up. So I've just got $5,862.89. Okay, and that is the end of 9.3. So remember,